Hello, everyone. Welcome back. Today, we'll talk about, as it says, solving an unusual exponential and logarithmic equations. So you may have already seen the videos I've done on solving both exponential equations and one on logarithmic equations, but these are ones that don't really fit into the kind of the standard way to solve them. They're kind of different. We'll take a look at a few examples. So our goal is then, specifically in doing this, to be able to solve exponential logarithmic equations using what's called a substitution, and then also be able to solve exponential and logarithmic equations in what's called quadratic form. We'll explain each one of those. So using substitution, what this means is it says sometimes it's helpful to use a substitution to write a complicated equation in a simpler form. Okay, so let's take a look at our first example and kind of give you an idea of how that can work. So let's go over here to the right and kind of explain both and also in one in quadratic form as well. So our directions would just be to solve. Number one, let's say we have this 4 times e. All right, write that better. 4 times e to the 2x plus 7 times e to the x equals 15. Now, this is an exponential equation because our variable is in the exponent, but it doesn't really fit in the kind of usual rules of solving an exponential equation. It's not one exponential equation equal to another or something like that. So I also want to notice is, as we'll see, we can write this in what's kind of a quadratic form. And what I mean by that is basically an equation in quadratic form is an equation that can be written in the form of make it look like a quadratic equation. So we're actually going to do that and use this with substitution as well. So what we're going to do then to make this a simpler equation is we can use a substitution. Okay, and what I'm going to do, I'm going to call, and since our variable is x, I'm going to use y. Let y equal e to the x. Okay, now, why do I do that? Well, what I want to do is make this a simpler equation to work with. So, what I have in common in both is an e to the x. Remember, e to the 2x is the same as e to the x squared. So what I can do then, let me say, so this, let this also, we'll say, and e to the 2x is the same. Remember rules of exponents, I can also write this as e to the x squared, because in this case, you multiply your exponents, so this is going to be y squared. And so our equation becomes this, 4 y squared plus 7y equals 15, okay? Now, hopefully you recognize this is clearly a quadratic equation. And so potentially we can solve it the way we usually solve any quadratic equation. In this case, this one will factor, but if you can't factor or have trouble factoring, you don't see how it factors right away, and so you understandably won't, then you may want to use a quadratic formula. So first, let's actually write this, the one side equal to 0. So first, let's write it like this. So we have 4y squared plus 7y minus 15 is equal to 0. Now, so now we're going to take the time on deciding how I factor. Once again, if you have trouble factoring, you always use the quadratic formula. But if you factor it, what this is going to become is this is going to be 4y minus 5 and y plus 3. If you're unsure, just always multiply it back through, make sure you get the same thing. Now remember, in factor form, what we do is set each factor equal to 0. And so we have 4y minus 5 is equal to 0. And then we have over here, y plus 3 is equal to 0. Now, if you solve this, you'll have y is equal to 5/4 and y is equal to negative 3. Now, what I want to do now is substitute back. So substitute back, so put it back in terms of e to the x. And also I should say back over here. So my method was choose an appropriate variables substitution to apply, and also why I chose to use it was a quadratic form is basically we have from this, we can see essentially we have e to the x and e to the x squared. So we have a term to the first power and a term to the squared. A lot of times we can, so in some cases we can write it as essentially as a quadratic equation like we did here. Now, substitute back, remember e to the x, y equals e to the x. So let's write this then, as we have two equations. E to the x is equal to 5/4, and e to the x is equal to -3. Okay, now we have two equations which we can now solve using our normal ways we solve exponentials. Now, first thing you want to notice is this side right here. In fact, let me, instead of using a comma, let me separate these with a line. This part here has no solution. Okay, remember e to the x is always positive or 0, or in fact, it's always positive. It's not even equal to 0. So actually, this part has no solution. You can't find an x will make this true. And if you try to take the log of both sides, you'd see you'd be trying to take the log of a negative number, which you also know that you can't do. But over here, let's solve this. So let's take, on this side, let's take the log of both sides, take natural log of both sides. You can take any log you want, but natural log is the best in this case because that's the inverse of e. So take ln of both sides. And if we do that, then we have the natural log of e to the x equals the natural log of 5/4. Okay, of course, natural log and e cancel each other out. We have that x is equal to natural log of 5/4. And if we approximate that, that's the exact answer. If we approximate it, give me a moment and do that. And let me find my, there it is. And that's going to be approximately, to three places, this will be approximately 0.223. Okay, so that's then the solution to this equation. So once again, what we did is we recognize this is sort of a quadratic form because we have essentially e to the x and e to the x squared. So to make it look like a quadratic equation, we did a substitution, replace e to the x with y, call that y just to make it simpler, easier to work with. Okay, then we solved this, in this case, by factoring. Of course, you always use the quadratic formula to solve any quadratic equation. Okay, got those solutions of the quadratic equation, substituted back in terms of e, and then finished it, and then found this is our solution right here. And once again, we have no solution over here because a exponential function can never be negative. Okay, now let's take a look at the second one. All right, number 2, let's say we have this. So we have log of z squared is equal to log of z to the 7th. Okay. Now, here again, this is a complicated equation. It doesn't really fit into the usual ways of trying to solve a logarithmic equation. So a couple things I want to do. First off, let's use one of our rules of logs. Let's bring this. Let's take this and bring this down front. That's one of our rules of logarithms. So we can rewrite it as log z, so our left-hand side stays the same for now, is equal to 7 times log z. Now let's go ahead and make one side equal to 0. So I'm going to subtract this term from both sides. I'm going to have 0. We're going to have over here log z squared minus 7 log z. Okay. Now, once again, if you notice, this is similar to the first one you did. We have log z, the first power, just log z, and then log z squared. So once again, this is a quadratic form. Okay. Let's use another substitution. Okay. This time I'm going to use the letter u, which is often common in math for some reason. I'm not sure why it is, but if you take calculus, you'll often do a u substitution. So u equals log z. Okay. Now, I'm going to plug that in for our equation, substitute into our equation. Then if I do that, that's obviously going to give me then u squared minus 7u is equal to 0. Okay, now I definitely do have a quadratic equation here. You can see that. Now this one you can also solve with the quadratic formula. But actually, the easy way to do this one is also to factor. In fact, this is a form where it's guaranteed to be able to factor it, because I can always take out a u. I'll just say factor. I take a u out, have u times u minus 7 is equal to 0. Like before, set each factor equal to 0. U is equal to 0. U minus 7 is equal to 0. Whereas here we have u 0, and then if I add 7 to both sides, u is equal to 7. Now, once again, once to substitute back. Put this back in terms of log z. And so once again, I have two equations, log z. And remember that log is log base 10. Log z is equal to 0. And log z is equal to 7. Now, the way to solve this, for this one, you don't have to maybe do a solution if you recognize where log is going to be 0 is actually at when x is 1. But what we can do to get rid of the log is basically put both sides, in both cases, put both sides to a base of 10. Since this is log base 10, both sides to base 10. So we have 10 to the log z is equal to 10 to the 0. And then, of course, we solve that. Base 10 log base 10 cancel each other out. So we have z, and of course, 10 to 0 is 1. That's one solution. And also, one thing I have to make sure we check is you have to make sure you plug this back in. And we always have to check a logarithmic equation. Make sure if you plug it back in, you're not going to get try to take the log of a negative number. Okay, so I plug this back in here. This will be log of 1. That's okay. And same thing up here. Put a log of 1, you get 0 in each case, so that's all right. So I'm not going to show it formally checking, but that's how we check it. Okay, same thing, both sides of base of 10 over here. So 10 to the log base 10 of z is equal to 10 to the 7th. These cancel out, so z is equal to 10 to the 7th, and that's going to be actually 10 million. And once again, make sure you're not taking the log of negative number, being our original equation. And so, of course, this is positive, so this is good here. Log of a positive is okay. Back here, it's all right as well. In this case, we have two solutions then. Z can be 1, and Z can be 10 million. Those are our two solutions. All right. Now, let's do one more problem. And this one doesn't really fit either one of those situations. This is kind of a strange one, but let's talk about it. Let's say I have log. Actually, let me do natural log. So let's say I do natural log of the natural log of x is equal to 0. Okay. Now, this doesn't really fit either one of those cases, the special cases. This is something a bit different. All right, but here we can still once again use the substitution. This is not a quadratic form also. This is not a quadratic form. This is something different, okay? I'll still use the substitution, okay? I'm going to let natural log of x be equal to, let's call it, let's use u again. I'll let u equals natural log of x. Okay, plug that in, then I have natural log of u is equal to 0. Okay, now, just as I did up here, I don't have to repeat this, but basically, if remember, log of any log of 1 is always 0. So you could put both the sides of this to base e, that would solve it, but basically the solution is essentially going to be u equals 1. Okay, for the first part. Now we're not done. I want to substitute back. Okay, put this back in terms of natural log of x. Okay, and so then that's going to be the natural log of x is equal to 1. That's what u is. I want to solve this. So this is where I actually want to put both sides to base e. Okay, So you have e to the natural log of x is equal to e to the 1. Of course, e and natural log, remember natural log is log base e. These cancel out. Then I have x is equal to e to the first, which is just e, which is approximately 2.781. Okay, and then that's our solution. Like I said, that one didn't really fit either, didn't really fit the quadratic form. I thought it was useful to look at that one. You can still use this substitution then to make it easier. So what we learned today are just kind of look at some unusual situations you can come up with sometimes in solving logarithmic and exponential equations don't fit the typical solution methods. That's what we're going to take a look at today. And so we saw some basic ways of solving that. And this, of course, there are many other ways to come up with unusual equations. This doesn't cover everything. This just covers some common ones you might see. Thank you. Have a good day. Oh, also one more thing, I should say this. Once again, we need to make sure we check this to make sure it's okay. Yeah, here's logarithmic equation, make sure we check. So make sure we're not taking a natural log of a negative number or 0. All right. So natural log of e is 1. That's a positive number. That's fine. Take a natural log of negative number. And also here, natural log of x is going to be 1, and that's fine. So ln of x is 1. So if we plug that in, natural log of 1 is 0. That's also fine. So that checks out fine. Okay, good. So now, thank you. Have a good day.